So these are tricky, so I'm going to show you how to solve the first one. I think it's tough. So when I see a problem like this, I know I need to calculate the force of electricity and the force of gravity. And then I want to calculate the total force. So what I'm going to do here, the very first thing I'm going to do is I'm going to think about which way are the forces going. So, and you don't need to draw this in if you don't want, but you certainly can. I know the force of gravity is always going to be going towards each other. So if I want to think about the force of gravity, I know the force of gravity is always moving towards one another. Let's make gravity blue. That would be fun. Okay, so we know gravity is always moving towards each other, and so I made these arrows to represent that. Now let's think about how electrostatics can work. So we know electrostatics will go towards each other if we have opposite charges, and they'll go away from each other if they have the same charge. So these are both positive charges. They're both positive charges. And so we know the force is going to be pushing away, right? Because opposites or the same charges repel. We have a positive charge, same charge, these are going to be repelling. If this was a negative charge, they would attract. So we know the force of electricity is going to be going away from each other. Let's make electricity green. All right, so we now have the force of gravity and the force of electricity and their directions. We don't know how much force these two things have, which is a problem because we're going to need to calculate that to answer this question. So let's do this thing. So the first thing, let's calculate electric force first because we've been doing that recently. So Q1, in this case, I'm going to just choose the one on the left, arbitrarily be Q1. I'm going to fill out all of our numbers here. Remember, we're applying this formula, right? K times Q1 times Q2 divided by D squared. This is this constant K, huge constant, times the first charge times the second charge divided by D squared. All right, so I'm going to do positive 2 times 10 to the negative 6. All right, good. Q2, I'm going to use the one on the right here. I'm going to pick this one for Q2. This is going to be positive 1.5 times 10 to the negative 6. All right, and the distance between them, 1 meter. Awesome. All right, let's find the force. Now to find the force, you're going to need to go over here. You're going to need to go to your calculator. So let's pull up Coulomb's law calculator. We're going to open that right up. I'm going to bring it right next to my solving tab, so it's easy to switch back and forth. And I'm going to put those numbers in. Actually, I can make those 2 windows. Let's see, that would be fancy. All right, nope, that didn't go great. Hold on. All right, so we can plug these all in. So I have the charges set to not equal. Now, notice here, my units are wrong, so I'm going to change them. So I'm going to set this to coulombs. My units are in coulombs. Sorry, I'm probably writing in coulombs. All right, so my charges are in coulombs. Let me make sure my charges are in coulombs. And my distance is in meters. So that's going to be important. So my first charge is 2 times 10 to the 6 coulomb. 2 times 10 to the negative 6 coulomb. So remember that instead of writing 10 to that, we write E, negative 6. This is 2 to the negative 6. You'll know that it'll turn it into a decimal. So if you'd like to convert this into a decimal first, you can type it out as a decimal. That'll go just as well. And we have 1.5 times 10 to the negative 6. See, I almost forgot to switch this to coulombs. Let me show you a problem here. If you type it in first and then switch it to coulombs, see how the number changes? We can't do that. So I got to erase and delete those first. Now I'm going to switch to coulombs. Now I'm going to write in 1.5 times 10 to the negative 6. All right, now before I type my meters, I'm going to make sure our force is set to newtons. We want our force in newtons. I'm going to say 1 meter. And this is our force electric. So the force of electric is going to be 0.0 449. You can convert that to scientific notation if you'd like. If you convert this to scientific notation, that's going to be equal to, I'm going to move this decimal point over 1, 2 times, you can get 4.4, 9 times 10 to the negative 2. All right, excellent. Now let's look at gravity. So if we want to do gravity, we don't want the same calculator. We want to go get our gravity calculator, right? Let's go get our gravity calculator. I'm going to go back to our class here. I'm going to go pull up gravity. We're going to go scroll all the way down here. Go get our gravity calculator back from February. Grab this guy. It works just the same. As you remember, now I've set it. This one's set properly for some reason. Set to kilograms, meters, and newtons. So we're all set. Make sure that you are set to kilograms, meters, and newtons there. We know that our first mass, we're going to use the one on the left still, it's going to be 10 kilograms. Our second mass is going to be 6 kilograms. And the distance between the two is going to be 1 meter. Boom. All right, great. That was easy. We've got all that. Let's plug it in. So now we have 10, 6, 1. Look at this tiny number. I'm going to convert it to scientific notation because I don't want to type all this. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 4.0 times 10 to the 9th newtons. 10 negative newtons. All right, so we have these two forces. And you might want to be thinking right now, okay, which one of these is stronger? And you probably already can tell because this is times 10 to the negative second. This is times 10 to the negative ninth. This one is a lot larger, right? You're divided by 10 only 2 times, we're divided by 10 9 times. So you can tell that our force of electricity is a lot larger. All right. So I'm going to put another text box in here. I'm going to get our total force. To get our total force, we need to subtract our numbers. Let me give you, if I give you a little hint here, if you take the force, this force electric, if you take the gravitational force, this gravitational force F, and subtract the electric force, you are always going to get the correct amount of total force. The reason for this is if this force number is negative, then by subtracting, you're essentially adding, right? So if you're subtracting a negative, you're adding a positive. So in this case, right, where it's positive, you're going to be subtracting a negative, and so you're going to end up with a negative number. So the directionality is a little interesting. You're going to think about the directionality very carefully as you move through here. So let's actually do this out. We have 4.0 times 10 to the ninth. Minus 4.49 times 10 to the second. Now this number, this second number, is so much larger. Right? The second number is like 7,000 times larger than this one, and we're rounding so greatly, you're not even able to notice the subtraction. So feel free to punch this into your calculator. Really do that, but we're going to actually end up with after rounding, would end up with negative 4.49 times 10 to the negative second. And then the last thing you have to answer here is, will these two objects move closer together or farther apart? That's what we care about. That's what we're working on. So this is their total amount of force, right? There's the total force. But which direction is it going? Well, we know that electric is moving out and gravity is moving towards one another. Which one's stronger? Well, we know this one's stronger, right? It's got this, it's got a less of a negative exponent, it's got a less negative exponent. So electric is much stronger. We have a much stronger electric force than gravity, so much that gravity almost doesn't affect the situation at all. So these objects can move apart. And we know because they are both positively charged. So they will repel one another. And electricity is stronger than gravity in this case. That's how you solve this problem. Several steps. If you have any questions for next time, I'd be happy to work through a couple of these with you. But go ahead and do the other 4 of these on your own. Again, and I'd love to help with any questions. Thanks so much.